Jai Hind everyone. Today we are starting with the chapter 3 of NCERT Class 11 Physical Geography, that is interior of the earth. So let's get started. The configuration, we are starting from here. The configuration of the surface of the earth is largely a product of processes operating in the interior of the earth. So what are the processes operating in the interior of the earth called? They are called endogenic. And if the processes are happening outside the interior of the earth, they are called exogenic. Exogenic as well as endogenic processes are constantly shaping the landscape. A proper understanding of the physiographic character of a region remains incomplete if the effects of endogenic processes are ignored. Human life is largely influenced by the physiography of the region. Therefore, it is necessary that one gets acquainted with the forces that influence the landscape development. To understand why the earth shakes or how a tsunami wave is generated, it is necessary that we know certain details of the interior of the earth. So let's go to the sources of information about the interior. We all know that the Earth's radius is about 6,400 kilometers and 6,378 kilometers in precise. But no one can reach the center of the Earth and make observations to collect samples of the material. Under such conditions, you may wonder how scientists tell us about the Earth's interior and the types of material that exist at such depths. Most of our knowledge about the interior of the Earth is largely based on estimates and inferences. Yet, a part of the information is obtained through direct observations and analysis of materials. So, we have two divisions under sources of information, that is, first one direct sources, and the second one is direct sources. Let's see the direct sources first. The most easily available solid earth material is surface rock or the rocks we get from mining areas. So the first direct source is earth materials or the surface rock that we or the rocks we get from mining areas. Gold mines in South Africa are as deep as 3 to 4 kilometers. Going beyond this depth is not possible as it is very hot at this depth. Besides mining, scientists have taken up a number of projects to penetrate deeper depths to explore the conditions in the crustal portions. Scientists are working on two major projects such as Deep Ocean Drilling Project and Integrated Ocean Drilling Project. The deepest drill is at Kola, which is in Arctic Ocean, and it has reached a depth of 12 kilometers. So what is the deepest drill on the earth? It is at Kola in Arctic Ocean and has reached a depth of 12 kilometers. And the next direct source is volcanic eruptions. What happens in a volcanic eruption? The magma, which is from the mantle, comes all the way to the surface of the earth, bypassing the crust. So this can give some a detailed information about the interior of the earth also. Volcanic eruption forms another source of obtaining direct information. As and when the molten material, that is magma, is thrown onto the surface of the earth during volcanic eruption, it becomes available for laboratory analysis. However, it is difficult to ascertain the depth of the source of such magma. So, in the direct source of magma, we can find the chemical composition. We can find the different types of material that are available in the interior of the earth, but we don't have an opportunity to determine from which depth this magma has been thrown out to the surface of the earth. And after completing direct sources, now we have indirect sources. Let's see. Analysis of properties of matter indirectly provides information about the interior. We know through the mining activity that the temperature, pressure increase with the increasing distance from the surface towards the interior in deeper depths. Moreover, it is also known that the density of the material also increases with depth. What does it mean? So, if the density of the material that is at 1 kilometer from the surface is lesser, than the density of material that is located more than 1 kilometer, that is either 5 kilometers or 10 kilometers. So from this, we can conclude that as we move from the surface to the center of the earth, the density of the material increases along with the increase in temperature and pressure. It is possible to find the rate of change of these characteristics. Knowing the total thickness of the earth, scientists have estimated the values of temperature, pressure, and the density of materials at different depths. The details of these characteristics with reference to each layer of the interior are discussed later. Another source of information are the meteors that at times reach the earth. However, it may be noted that the material that becomes available for analysis from meteors is not from the interior of the earth. So, does a meteor has the same material as it has in the earth? No. The material and the structure observed in the meteors are similar to that of the earth. So this is why this could be one indirect source to study the interior of the earth, because the material and the structure in meteor and the earth are similar. Meteors, they are solid bodies developed out of materials same as or similar to our planet. Hence, this becomes yet another source of information about the interior of the earth. So what are the two indirect sources we have learned? That is properties of matter which indirectly provides information about the interior, and the second one is meteors. The other indirect sources include gravitation, magnetic field, and seismic activity. The gravitation force is not the same at different latitudes on the surface. So the gravitation force is greater near the poles and less at the equator. Why is it? Because the distance between the pole and center of the earth is less than the distance between equator and the center. So we can see the maximum influence of gravitation near the poles and less at the equator. Here they have given the reason. This is because of the distance from the center at the equator being greater than that at the poles. The gravity values also differ according to the mass of material. So on which does the value of gravity depend? Mass of material. The uneven distribution of mass of material within the earth influences this value. The reading of the gravity at different places is influenced by many other factors. So the reading of gravity apart from mass of material is influenced by many other factors. These readings differ from the expected values. Such a difference is called gravity anomaly. So what is a gravity anomaly? The difference between the expected value of gravity to the actual gravity value is called gravity anomaly. Gravity anomalies give us information about the distribution of mass of the material in the earth crust. So what is the use of gravity anomaly? It gives information about distribution of mass of material in the earth's crust. Magnetic surveys also provide information about the distribution of magnetic materials in the crustal portion and thus provide information about the distribution of materials in this part. Seismic activity is one of the most important sources of information about the interior of the earth. Hence, we shall discuss it in some detail. So among the indirect sources, we are going to discuss the seismic activity in detail. So in that first one is earthquake. What is an earthquake? An earthquake, in simple words, is shaking of the earth. An earthquake is a natural event. It is caused due to release of energy which generates waves that travel in all directions. So in an earthquake, during an earthquake, and why does an earthquake occur? It is caused due to the release of energy which generates waves that travel in all directions. And the next question is, why does the earth shake? The earth shakes because of release of energy that occurs along a fault. A fault, what is a fault? A fault is a sharp break in the crustal rocks. So when there is a fault in the crustal rocks and there is a release of energy along it, then an earthquake can be generated. Rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes a release of energy. So, this is the reason why the energy is released, and due to that, uh, there is an earthquake. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called focus of an earthquake. Also, it is also called hypocenter. So, where is the focus located? It is at a point where the energy is released. So, the focus is also known as hypocenter. The energy waves traveling in different directions reach the surface, and the point on the surface that is nearest to the focus is called epicenter. So, epicenter is the point that is on the surface of the earth, whereas focus or hypocenter can be in the earth's crust or below the surface of the earth. So, from the epicenter, it is the shortest distance between the focus and epicenter. It is the it is the first one to experience the waves. Which is the first one? Epicenter. Epicenter is the first one to experience the waves. It is a point directly above the focus. Next, we will see the earthquake waves. All natural earthquakes take place in lithosphere. Where does the not natural earthquakes take place? Lithosphere. It is sufficient to note that here the lithosphere refers to a portion of depth up to 200 kilometers from the surface of the earth. So, what is the uh, depth of lithosphere? That is 200 kilometers from the surface of the earth. An instrument called seismograph records the waves reaching the surface. What is the instrument? Seismograph. And what does it do? It records the waves reaching the surface. A curve of earthquake recorded on the seismograph is given in figure 3.1 if we see here. So these are the waves that are recorded on seismograph after the waves reach the surface. Next. Earthquake waves are basically of two types. What are the types of earthquake waves? One is body waves and next one is surface waves. Body waves are generated due to the release of energy at the focus. So where do we find body waves? That is in the earth's crust or interior of the earth, that is far away from surface of the earth. So the body waves are generated due to the release of energy at the focus. They move in all directions traveling through the body of the earth, hence the name. Hence the name body waves. The body waves interact with surface rocks and generate new set of waves called surface waves. So where do we find surface waves? When the body waves, which are traveling through all direction, and when they interact with the surface of the earth and with the surface rocks, they generate surface waves. These waves move along the surface. Which wave? Surface waves. The velocity of waves changes as they travel through materials with different densities. The denser the material, the higher is the velocity. So the velocity of the wave is directly proportional to the density of the material it is passing through. Their direction also changes as they refract when coming across materials with different densities. Next, we'll see the types of body waves. So under body waves, we have two types, that is P waves and S waves. P waves stand for primary waves. These are similar to sound waves. So a sound wave travels through all media, that is liquid, solid, and gaseous. So P waves also travel through gaseous, liquid, and solid materials, whereas sorry, and P waves are the first to arrive at the surface. So, what are the properties of P waves? P waves are called primary waves. They are similar to sound waves as they travel through gaseous, liquid, and solid materials. They are the first to arrive at the surface. But when we come to the S waves arrive at the surface with some time lag. So that's why they are called secondary waves. An important fact about S waves is that they can travel only through solid materials, while P waves can travel through all three media. S waves can travel only through solids. SS. So S wave only through solids. This is quite this characteristic of the S waves is quite important. Why? Because it has helped scientists to understand the structure of interior of the earth. Reflection causes waves to rebound, whereas refraction makes waves to move in different directions. This variation in the direction of waves are inferred with the help of the record on seismograph, and the surface waves are the lost to report on seismograph. The surface waves are more destructive and they cause displacement of rocks and help, hence the collapse of structures occurs. Let's have a quick overview because I think the information is very much packed in a single paragraph. So under earthquake waves, we have two divisions. One is body waves and the second one is surface waves. The body waves are generated due to release of energy at the focus. These body waves travel in all directions, and when they interact with the Earth's surface or the surface rocks, surface waves are generated. Next, in body waves, we have two types, that is P waves and S waves. P waves are called primary waves, and they are the first to arrive at the surface. P waves are similar to sound waves as they travel through three media, all the three media, that is gaseous, liquid, and solid materials. And the next one is S waves. S waves arrive at the surface with some time lag, so that's why they are called secondary waves. The important characteristic of S wave is that they travel only through solids. So these are the P waves and S waves under body waves. And the next, the surface waves are the last to report on seismograph. And these waves are more destructive because they cause displacement of rocks and hence the collapse of structures occurs. But why does learning about waves help the scientists to understand the structure of interior of the earth? We'll see with the diagram. So if you see the P wave and S wave shadow zone, you can see if we consider this is the focus, which is to the near of North Pole, if we consider, the wave started traveling through all directions if we see. So when they reached a point where the density of the material varies from its current material, the wave started refracting here. If we see the current, this path should be here, but it has been refracted and has come through in a different direction. So according to this, we can conclude that there is a density difference between the materials, and it has helped to construct the structure of the interior of the earth, because P waves travel through three media, that is gases, liquids, solids. Due to that, we have seen a shadow zone of between 105 degrees and 145 degrees on both sides. But when we come to S wave shadow zone, the waves couldn't travel through the core. The waves weren't refracted and they couldn't travel through the core. And we have learned the characteristic of S wave, that it travels only through solid. So we can conclude that uh, core is something that is not solid. So from this we can conclude that the core is not solid, while the crust crust is crust is solid, as we know, but the core is not solid. So from this we can conclude that core is a liquid portion. And the similarities between P wave and S wave shadow zones are, there is a shadow zone between 105 degrees and 145 degrees in P wave shadow zone on both sides, while anything beyond 105 degrees in S wave shadow zone is there is no direct S waves received here. So S wave shadow zone is more than P wave shadow zone, but in both the similarity is it is a shadow zone between 105 degrees and 145 degrees. So this is how the study of waves helped scientists to construct the interior of the earth. Next, the next one is propagation of earthquake waves. Different types of earthquake waves travel in different manners. As they move or propagate, they cause vibration in the body of rocks through which they pass. P waves vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of propagation. As a result, it creates density differences in the material to leading to stretching and squeezing of the material. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibrations of S wave is perpendicular to the wave direction in vertical plane. Hence, they create troughs and crusts in the material through which they pass. Surface waves are considered to be the most damaging waves. So here, if this is a P wave, it moves in this direction, that is parallel. If the wave has to move from this point to this point, and the wave propagates like this. So it creates stretching and squeezing of material, while the S wave moves perpendicular to its direction like this. So this is the difference between P wave and S wave. In P wave, we have parallel propagation, and in S wave, we have perpendicular propagation. This emergence of shadow zone, as I've explained here, it is the same. Next, we'll see types of earthquakes. The most common ones are the tectonic earthquakes. These are generated due to the sliding of rocks along a fault plane, which we have learned as the natural earthquake before. Next, a special class of tectonic earthquake is sometimes recognized as volcanic earthquake. However, these are confined to the areas of areas of active volcanoes. And next we have collapse earthquakes, which are caused due to the areas of intense mining activity. And we have ground shaking due to the explosion of chemical or nuclear devices. Such tremors are also called explosion earthquakes. And the last one, we have reservoir induced earthquakes, where the earthquakes that occur in the areas of large reservoirs. These are called reservoir induced earthquakes. And how are the earthquakes measured? So we have two, that is Richter scale and Mercalli scale. In Richter scale, the values are up to 10 from 0. The Richter scale estimates the magnitude of the earthquake. So it records energy released during earthquake. It doesn't have to do anything with the damage that occurred due to the earthquake. So in Richter scale, magnitude is estimated, and the values are 0 to 10. And the next one is Mercalli scale. It has numbers. The range of the scale is 1 to 12. Sorry, here it is written as 0, but the range of intensity scale is from 1 to 12. It records visible damage caused by the event. So what is the difference between Richter scale and Mercalli scale? There are three differences basically. One, Richter scale estimates the magnitude, that is, it records energy released during earthquake, whereas Mercalli scale is an intensity scale. It records visible damage caused by the event. And in Richter scale, we have its range from 0 to 10, and in Mercalli scale, the range is 1 to 12. While the seismograph, what is seismograph? It records the waves reaching the surface. So these are the three instruments that are related to the earthquake. Next, the last topic for today's video is effects of earthquake. Earthquake is a natural hazard. The following are the immediate hazardous effects of the earthquake. In this, the first 6 listed above has some bearings upon landforms. What are the first 6? Ground shaking, differential ground displacement, land and mud slides, soil liquefaction, ground lurching, and avalanches. These have some effect in the deformation of landform, the first 6, while others may be considered the effects causing immediate concern to the life and properties of people in the region. So from 7 to 12, these causes immediate concern to the life and properties of people in the region. These are ground displacement, floods from dam and levee failures, fires, structural collapse, falling objects, and tsunami. The effect of tsunami would occur only if the epicenter of the tremor is below oceanic waters and the magnitude is sufficiently high. So what are the conditions for the occurrence of a tsunami? The epicenter must be below, epicenter of the tremor should be below the oceanic waters, and the magnitude should be sufficiently high. These are the conditions for the occurrence of a tsunami. Tsunamis are waves generated by the tremors and not an earthquake in itself. Though the actual quake activity lasts for a few seconds, its effects are devastating, providing the magnitude of the earthquake is more than 5 on the Richter scale. So, when the devastation is more, if the magnitude is more than 5 on the Richter scale. So we have in this, the last is after effect of earthquake is frequency of earthquake occurrences. The earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to the life and property of people. However, not all the parts of the globe necessarily experience major shocks. We shall be discussing the distribution of earthquakes and volcanoes in the next chapter. Note that quakes of high magnitude, that is 8 plus magnitude, that is Richter scale, where the range is 0 to 10. And if the magnitude is more than 8, are quite rare, and they occur once in 2 years, whereas those of tiny types occur almost every minute. So these are some of the examples where we can see destruction caused by tidal waves in Marina Beach in India, Colombo in Sri Lanka, and tidal waves in Thailand, waves are by tidal wave. These are the examples of tsunami. So this is all for this video. We'll meet up at the next video. Thank you.